So in the previous class we learned IPv6 and IPv6 with all routing protocol. This class we are going to see how we are going to migrate from IPv4 to IPv6. Migration for customers or for network varies from one network to another. It won't be same method. Meaning, for example, if customer is telling you, you see, we are already into IPv4 and we do not want any downtime. We do not want any downtime. We need IPv6. In that case, we'll go with a method called dual stack. What does that mean? We'll have both IPv4 and IPv6 coexist on same interfaces. You see, on one interface you can have both IPv6 address as well as a IPv4 address. Even though it is one physical interface, they are handled separately. There are different algorithms, not the same algorithm. Yeah. So we can use different algorithm. Means not we, it uses a different algorithm and handles it separately. There's a separate controller for IPv6 and IPv4. There's a separate control plane actually. So we call it as dual stack. Because it is two separate process, the process utilization is going to be doubled. That's the only drawback of this. For example, R1 has already got 10.11.0.1, 10.11.0.2. And you may be running routing protocol like OSPF because you got many routers and many networks. I'm not willing to write all those networks. So you'll be running a routing protocol. Now, when you're going to assign an IPv6 address, like this, you will be running another OSPF for IPv6. See, there are two OSPFs now. So definitely the process utilization is going to be doubled. Even BGP. We saw the BGP commands look similar like IPv4, but you remember at last we put one command, address family IPv6 unicast. And then we activated the member. So that's an additional process. Address family IPv6 is an additional process. So this is the best solution, I tell you, which everyone knows as of now, to have IPv6 without interrupting IPv4 network. Very simple, no? You need to simply start putting IPv6 address everywhere. And then enable IPv6 routing protocol, and then they do communicate like IPv4. Routers communicate, they learn the routes. This will be a separate track, that will be a separate track. When all the IPv4 customers move to IPv6, then you can slowly remove IPv4. Boom. You see? This is how you can migrate an IPv4 to IPv6 step by step. First, enable IPv6 everywhere. Don't disable any IPv4. Whatever is running, keep maintaining it. Enable IPv6 IP address. Make your customer to get an IPv6 address from you. Once the customer, everyone move to IPv6, after you ensure that all the customers have got an IPv6 address, and the all applications that are running with IPv4 is now migrated to IPv6. After you confirm these things, you can stop the service, IPv4 service. That is very important. Check the compatibility before you disable IPv4. See, for that it will take a long time. As a first step, we need to assign IPv6 address on the routers inside the provider. And then ask the customer in the edge to do the same. See, they need to get an IP address from you or subnet from you so that they can communicate to you. Earlier, you gave IPv4, which is already running. Now you're giving IPv6. With that, now they are communicating. Now they also have double the process utilization. Now customer will try your IPv6 with all the application that he has got inside. And if he comes with some complaints, fix it. And then you can stop the IPv4 service. But for customer to accept IPv6, it will take some time because some applications that they are running may not support IPv6. Till the time you have to provide them IPv4 till they migrate the application to IPv6. We have to support IPv4. So no service provider will stop IPv4 service for another at least 10 years. Every application, has got a lifetime. Even if you buy a Cisco router, there is a lifetime. Likewise, every software that you purchase has got a lifetime. And that won't be more than 10 years. Like 2 years, 3 years. After that, end of sales. So when you upgrade, it is going to have IPv6 support. Every application developer develops their application to support IPv6 nowadays. Like your cell phones. All the new cell phone that you buy now, they have 5G support by default. You cannot have your 10 years old phone expecting 5G. That is end of sales. So migrating IPv4 to IPv6 without disturbing IPv4 network is possible. That is what I'm going to do as a project in the month of February for a country, for the entire country. There are 10 downstream ISPs and 5 upstream ISPs. For all, we are going to do IPv6 deployment. Okay, so this is the real practical necessary migration technique that you should know. But there is also one more, where the customer may be IPv6 head office, branch office, IPv6. Unfortunately, the provider is not IPv6 supporting. Provider is only IPv4 supporting, as of now assume. Of course, there are service providers currently available who supports only IPv4 in some countries. One of the country which I am going to very soon deploy IPv6 there. What do you do this in this scenario? If your ISP is IPv4, but you and your branch offices are in IPv6, and you want to communicate from head office to branch office using your IPv6, is it possible? Yes, it is. You see, the provider might have given you an IPv4 address. Let's say 1.1.1.1. For example, I'm writing. And here it may be 7.7.7.7. But inside the LAN side, you have IPv6 address. We can communicate. How? There is something called 6 to 4 tunnel, where we take the IPv6 packet, and before sending it out, we encapsulate with additional layer 3 header with 1.1.1.1 as a source and destination 7777. Inside is IPv6. In IPv6 also you have source address and destination address in the packet. This is additional IPv4 header. IPv6 header is encapsulated with IPv4 header. And our packet is delivered to 7777. And this is where the decapsulation happens and the original IPv6 is seen. And then the packet gets delivered and decapsulation happens, the original destination is seen and packet is delivered. Basically, it's an encapsulation and decapsulation. Kind of VPN, 64 tunnel. Ask me some questions on this. These are the two things that we currently use in production for migrating as a migrating strategy. The first one is dual stack. The second one is 64. Sometimes you may need 64. There is also 4 to 6. If in case ISP is in 6 and you are in 4, that is also possible. That we call it as NAT protocol translation, meaning you're translating IPv4 to IPv6 and vice versa, which is process consuming, not recommended. Heavy process consumption. What protocol? IPv4 protocol to IPv6 for protocol translation. That's very bad. Not at all recommended. No one uses this as a solution. NATPT maybe one of a tunneling technique, but not recommended. Maybe one of the migration technique, but not recommended anywhere in the documents. This is like natting. See, normal natting itself is bad. IPv4 to IPv4. IPv4 to IPv4, we do no natting. Sometimes we do from private to public, public to private. That itself is process consuming, not recommended. Now, removing an IPv6 header on every single packet and putting IPv4 header and vice versa, you know how much process killing. So not recommended. Yep, question please.
So this 64 and 4 to 6, is it only is it for all the users traffic from one place to another, or is it only for the control plane or for route exchange and all of that?
All user traffic. See, the customer has completely moved to IPv6, and they don't want any IPv4 source and destination anymore. All their communication, all the devices to which they communicate to and fro, they're already into IPv6. Why they need an IPv4?
Which includes hosts also, like their hosts are.
Yeah, every single computer. So between this head office and branch office, they don't want IPv4. So in that case, the 6 to 4 can be used if ISP is only 4. Don't talk about this one. This I just for your knowledge. I told you about 4 to 6. It's not recommended, not in use. This is one of the method called NATPT, but not really usable method. Now, you see, we got 6 to 4 tunnel where you take IPv6 traffic and encapsulate. Fine. Between your head office and branch office, you have IPv6. Now, what about internet? If you want to talk to Yahoo, assume you don't have IPv6 service to Yahoo. Actually, they do have. If you talk from IPv6, they'll respond with IPv6. But what to do? Let's just assume. Assume that you are the genius, your company is the genius company in the world. You have already migrated to 6 and no one else. Then you remember the first technique that I told you? That's the best one. What is that? Dual stack. Yes. No, the switch won't get downloaded. See, I repeat your question. Will the switch performance go down if I use dual stack? That's your question. Of course, there will be additional utilization, process utilization, but switches won't go down. You don't have that bad switches. Your company switches will be under that less than that end of sales time. So end of sales switch also will support, I tell you, but I can guarantee you something that you will not run out of CPU. Not that much. Just you're adding some additional load. If your switches are already crying, then don't do that. But I don't think switches nowadays they're very capable. Sorry, that is not dual stack I'm talking about. I am here talking about one switch, only one switch or one router, which has got IPv4 address as well as IPv6 address on every single interface, and which has got a separate IPv4 routing protocol, IPv6 routing protocol. on the same router. I'm not talking about two separate switches. One router which has got IPv4 address and IPv6 address on the same port, like this. It's not a stack of device, it's address stack. See, whatever I have covered today, it may look like simple, but I tell you, this is what the world needs today. Migration of IPv6 is only this much. All right. So, yes, please.
So this is essentially I see a NAT where you translate your traffic to P4.
Which one?
I mean, from the head office to the ISP.
Are you talking about 64? 64 is not NATing. 64 is additional encapsulation. You have IPv6 packet. Additionally, you have another IP layer, IPv4.
So which device does this? Is it
A router.
router can do it?
Yes, edge router.
And so so the router probably maintains some state of the traffic. Like say for example, it is translated in IPv6.
No, don't use the word translation, please. No, there is no translation. There is no translation. So there is no need of maintaining any state, any NAT table, nothing like that. It is according to the edge router. It is sending an IPv6 packet, and before sending, it adds additional layer only. So there is no alteration done to IPv6 header. Only additional layer is getting added before sending out, and then when it reaches the 7.7.7.7 router, that layer is completely removed and it will see another fresh IPv6 layer and find the destination there and deliver the packet. So there is no need for any table maintenance, or there is here nothing is removed and added. Everything is kept same. IPv6 is kept same, and
Do you have any lab related?
yeah, of course I'm going to do the lab. Of course I'm going to do the lab in our next class. The core, the ISP has got no knowledge about IPv6, but your packet still goes through the IPv4 network. It is because the upper header, the upper layer, there will be two layer 3 header in this packet. One is the inner layer IPv6, the other one is the IPv4 header, which has got the source and the destination. And now you will be wondering, like, how? There may be many branch offices. If I ping this address, from here, how the edge router knows that I need to send it to 7777? That is what the magic is, which we'll be seeing in our next class. See, I've made you to think now. Before I said the sentence, it was like, okay, it is possible. Now you started thinking, how is this possible? What if I have another branch office here? And it is 2000:2:/64. When I ping from here, 2002::64, the destination will be 8.8.8.8. Here, this will be 8.8.8.8. If I ping 1, the destination will be 7777. How the edge router knows this is what we are going to see in our next class. This will be a very interesting one, and we'll finish with this, the IPv6. When we finish this lab, we finish IPv6. This is what today's world uses to migrate 4 to 6.